Phytoplankton. They are similar to terrestrial plants because they contain chlorophyll and require sunlight in order to live and grow. Most phytoplankton are buoyant and float in the upper part of the ocean, where sunlight penetrates the water. They are producers.
Pregunta difícil de contestar porque hay muchos factores involucrados. La desaparición o la disminución de la cantidad de phytoplancton en el agua obviamente está causada por el aumento de productos químicos disueltos y obviamente también por los cambios climáticos. Para poder contrarrestar ese efecto, pues habría que reducir los contaminantes y evitar que haya un calentamiento de las aguas. Ambos procesos son largos y son difíciles porque deben empezar por los procesos educativos en la industria y en todos los habitantes del planeta Tierra. Por lo tanto, es un esfuerzo muy grande, pero si todos colaboramos podemos ayudar a disminuir el efecto.
So step 1, we collected water from the Pacific Ocean located here in Guatemala, and we went 150 meters down, which is where our phytoplankton is located at.
The correct temperature would be 20 degrees Celsius.
So for step 3, we will gather both our samples from the morning and the afternoon, and we will take them to the food engineering in la Universidad Mayor de Guatemala.
We're going to take notes on the time we have right there, on the temperature, on the atmospheric pressure, on the light, and the humidity of the room in order
for them to not have any bacteria that could affect our phytoplankton.
For step 6, we're going to have the 2 beakers of water A and water B. We're going to measure the grams of water in each container. Then we're going to measure the dissolved oxygen of each water. Then we have to take the temperature each water has to see if there's any variety in between the 2 types of water. Then we're going to take the conductivity of the water and then the pH.
Our control group, we will have to measure the same things we did before, but we will have to do it for the distilled water, which will be used as the control group of water A and water B.
Number 8, we have to heat or cool the waters in order to reach 20 degrees Celsius.
Now, for step number 9, we will have to have microscope lights, which are the thin glass you put in the stage clips. So we will label them A and B. This will have all the drops of water of the morning water and all the drops of water of the water B, which is the afternoon.
1 drop of water. And we're going to cover that with a thin glass. Then we're going to put the glass here in the microscope in the stage clips, and we're going to see it through the microscope to see how many phytoplankton are in an area. And we're going
Now, for step 11, we'll repeat step number 10 several more times. So we will have 6 microscope lights, 1 for morning water and 1 for afternoon water, and we will look in 4 areas of that drop how many phytoplanktons are located in.
Step number 14. We're going to add to the waters 5 drops of acetic acid for trial number 1, and we're going to put it in the microscope in a drop of water to see how many phytoplankton there are. Then in trial number 2, we're going to add 10 drops and do the same thing. Then in trial number 3, we're going to add 15 drops.
So for step number 13, we will add milk of magnesia to see how it increases the alkalinity in the water. So first we will add, for trial number 1, we will add 160 drops to see in 4 areas how it affected the phytoplankton, and we will do the same process in 4 areas with 200 drops of milk of magnesia, and then for 240 drops again of milk of magnesia.